All right, let's review completing the square. First, let's talk about A, because a lot of people will see that and automatically try to factor it, which is great. You should always do that, other than the fact that you're not paying attention to the directions. So if you saw t squared minus 8t plus 20 equals 0. All right, you're thinking, okay, what multiplies b 20 adds up to be negative 8? Well, definitely not a 1 and a 20. Remember, I don't worry about the positives and negatives until I figure out what numbers I'm going to concern myself with, because either adding or subtracting, you're going to get either some kind of 21 or 19. It's not it. Can't get an 8. 10 and 2. Now, I could get either a 12 or an 8, depending on whether I added or subtracted, positives, negatives, blah, blah, blah. So 10 and 2 look like they have potential. It's definitely not 4 and 5, because that's either going to make a 9 or a 1. Okay, so if you tried to factor it, you're like, the only way it's going to work is with a 10 and a 2. Well, it's just not going to work, because if they have to multiply be positive, they either both have to be negative, which would make them add up to negative 12, or they both have to be positive, which would make them add up to positive 12. And that doesn't work. So we need a way to solve quadratics that don't factor, which most of them actually in real life don't. So the first way they came up with is completing the square, which was based solely on pattern recognition, where you were looking at, okay, I know if I can get a square by itself, I'm in great shape. So let's create our own square. That's why they call it completing the square. So if you half negative 8, you get negative 4. And you square that, you get positive 16. Because we know how a perfect square trinomial works. Whatever number sits here, when you half it and square it, you get the number there. When you write it back as a perfect square, it's always the variable and then whatever you got when you had half of it. So it's just, we put in the one number that made that a perfect square. We added it to both sides because it's an equation. We have to keep it balanced. And then what do you square to get negative 4? Well, that's either positive or negative the square root of negative 4. So if I get t by itself, I'll add 4 to both sides. Square root of negative is 9. Square root of 4 is 2. And remember, that's two different numbers. That's 4 plus 2i and 4 minus 2i. And if you don't believe me, let's go pick one of those. Like if I put 4 plus 2i back in for t, I square it, I take away 8 times it, and add 20, I better get 0. This is 16 plus 8, 8, 16i plus 2i squared minus 32 minus 16i plus 20. 16i minus 16i goes. Let's see, 16 minus 32 is negative 16. Plus that 20, that's 4. Plus, oh gosh, duh. 2i squared, I didn't square the 2. Plus 4i squared, which is a minus 4, which is 0. So, yep, it did work, especially when I actually square it too. And I could do the same thing with this. If I plugged it back in for t, this thing would be true. On this one, but remember, the pattern only works if you have a lead coefficient 1. So the first thing I do in here is divide everything by 3, both sides by 3. And then I'd get my variables on one side, constants on the other. And then I'm going to do the same thing. I'm going to take that coefficient on the linear term. I'm going to half it. Oops, why is the pen not working? Come on. Well, still not working. Eraser's not working either. There it goes. Let's put it up here and see. Oh, right there. Okay. Half it and square it. So if I half a negative 3, it's negative 3 halves. If I square that, it's positive 9/4. So I'm going to add 9/4 to both sides. That created a perfect square over here of x minus 3 halves all squared. If I get a common denominator, 3 and 4 both go into 12. So 3 times 4, that's going to be what, 23 twelfths? Oh no, we're going to have a little issue here because we haven't talked about what to do when this shows up. And I guess I should go ahead and get it to this point. 3 halves plus or minus, don't know the squared 23. 12 is 4 times 3, so that's 2 on squared 3. So for what we've discussed so far, this is how we leave it. This is another one of those things that you should have learned at the end of Algebra 1. Pretty sure you didn't learn it. It's just customary to never leave radicals and denominators. So remember, you can always multiply anything in the world by 1, and it stays worth what it is. So if I take that 1/2 of the fraction, like this part right here, and I multiply by √3 over √3. Okay, √3 over 3 is 1. I'm not going to change this value. I'm just going to change the way it looks. So I get the square root of what? 69 in the top. And then square 3 times square 3 is just a 3. And then you times in that extra 2, you get a 6. Now, let's say you're taking standardized tests. They may write that with a common denominator of 3, which would be like that. And that's perfectly okay also. Why did I say, oh my gosh, common denominator of 6. Ugh. It's not even as early in the morning as it usually is when I do this. I'm still messing up. So times 3 times 3. All right. Now, remember I told you that it was weird for me to have to do the x equals negative b over 2a to find the vertex or parabola? Yeah, that was weird because when people know how to complete a square, there's zero reason to do this. Like, here's just a parabola, a quadratic function written in standard form. Up until today, if you want to know its vertex, we need to do this. So we go x is the opposite of b over twice a. So you know the x value of the vertex is 6. And then you would take and see what y value we get when we plug in x being 6. So 6 squared, 12 times 6. This will be a negative 36 plus an 18. What's that? Negative 18. So the vertex would be that. Okay. When people know how to complete a square, you just don't do that. What they do is they try to get it into this form right here, because I think everybody agrees vertex form is the easiest form. Well, to get it into that form, you need to complete a square. So what I'm going to do is I'm going to take the part with the x's on it. I'm going to group it together and just shove that plus 18 out on the end. Okay. All right. So half of negative 12 is negative 6. If I square that, I get 36. Now, I just changed it. Remember, the part in the green is the same as this. They're equivalent. I've changed that. So this would not graph the same equation that the one before it did. And remember, I could add 36 to both sides and keep an equation balanced. Or another thing I can do is I can add 0 to one side. So I'm going to do that. If I threw in a positive 36 on the right, I could balance that out with a negative 36 on the right. Because I like that y over there by itself. And then I created my own square. I've got a minus 18 on the end. It means I move 6 to the right and down 18. And there's my vertex, where I get both halves of it. Like I get the x and the y in the same work. It's just so much easier. Okay. But if you're going to do this, when you complete a square, you have to have a lead coefficient 1. And you don't want to just divide both sides by 2 on this one because it's not set equal to 0. Like, we're just going to factor the 2 out. Okay, we're going to complete the square. Half of 12 is 6. 6 squared is 36 again. But this time around, I didn't just add a 36 to the right side. I added a 72 to the right side. So I'm going to take it right back out. And that gets me 16 minus 72 is what? It's definitely negative 12, 6, 6, negative 56. So that vertex, because I go 6 to the left and down 56, is at negative 6, negative 56. Okay. All right, this one, x squared plus 3x. You just don't have anything on the end, which is okay. So when I complete the square, half of 3 is 3 halves. If I square that, I get 9 fourths. So I'm just going to take it right back out. So my vertex is at negative 3 halves, negative 9 fourths, because I go 3 halves to the left and down 9 fourths. And then we can also use these algebra skills that we've been developing to work better geometry problems. So here's one. You got the length of a rectangle is a centimeter less than twice its width. So let's say W is its width. A centimeter less than twice that would be the length. And the area of this sucker is 45. Well, the area of a rectangle is just a base times a height, or a length times a width. So if the area is 45, and these are my two dimensions, I'm going to get to there. Okay. There's several things we can do right here. Let's say you want to do it with completing the square. If I do that, I need to divide both sides by 2. And half that negative half is a negative fourth. If I square that, I get plus a 16th. So over here, I've got W minus a fourth all squared. If I get a common denominator, a 45 times 8. I don't feel like thinking too hard this morning. That's 360 plus one more. So I'm going to get 361 over 16. So what do I square to get that? Either positive or negative, the square root of 361 over 16. Add the fourth to both sides. Square root of 361 is 19. The square root of 16 is 4. So I get two different things that W can be. 1 plus 19 is 20. Those both over 4. 1 minus 19 is negative 18. So the width is either 5 or negative 9 halves. Okay, well, the width can't be negative. So that doesn't even make sense. Could it be 5? Sure. Could it be 5 times 2, 10 minus 1, 9? Sure. So the width is 5 centimeters. Oh, they want the dimensions, though. So it's going to be, there's 5. 2 times 5 minus 1, 10 minus 1. There's 9. So it's a 5 centimeter by 9 centimeter rectangle. Okay. Now, the fact that I got those answers right there, those are rational numbers, means that I could have factored. So let's practice that up. I got a trinomial with a lead coefficient not 1. So I'm going to do my trial and error. Multiply to get 45 in some way. Let's try a 9 and a 5, because right there is a 10W. Here's a 9W. I can make a negative 1 if I do my signs right. They have to multiply to be negative 45, so the 9 and the 5 need to be different signs. I want them to add up to be negative 1W, so the 10W needs to be negative, and the 9W needs to be positive. Okay, so remember, this is saying that 2W plus 9 is 0. So W is either negative 9 halves, or if W minus 5 is 0, then W is 5. Therefore, W is either negative 9 halves or 5, and we already threw this away, and so we get the same answer. All right, so factoring is easier, it's quicker if you know how to do it. Now, I have decided to relent and show you the little method, because if you're still struggling with the trial and error, then we need to find an alternative. You just got to trust me on this, though. Don't give up on the trial and error. You only get good at it by doing it. And then when you get good at it, you get real fast. Okay? But there is another way. So what I'm going to do is I'm going to take something that's already in factor form and multiply it out. So if I'm going to distribute the 2x, distribute the negative 5, and put it back. Oops, oh, I got an 11 right there. Okay, so this and this are equivalent. Okay, what you've been doing here lately is starting here and going to there. Okay. So you're trying to get in factor form, and we've been trying, how do you multiply to get the 6x squared? How do you multiply to get the negative 10? Play with the numbers until the negative 11 shows up. Here's the method. I'm going to say it. I need you to write it down. Okay? If you multiply those two by each other, you get negative 60x squared. Okay, so what I'm going to hunt for, when the lead coefficient is not 1, if you don't want to do trial and error, is what multiplies to be that product of the first term times the last term and adds up to be the middle. Okay, so 15 times 4 is 60. Okay, what if I did a 15x and a 4x? And if I wanted to multiply to be negative, they have to be different signs. Add up to negative 11. I need the negative 15x and the positive 4x. So what you do, you figure that out. How can I make this happen? Then you replace the middle term with those two terms. And then you factor by grouping. So I'm going to take a 3x out of both of those. I'm going to take a positive 2 out of both of those. And then this and this both have a 2x minus 5 as a factor. And that leaves a 3x plus 2 left over, which is factored form. Okay, so that's the alternate way to do it. Let's try one. You multiply the front and the back. And then you hunt for the terms. What multiplies to be negative 150x squared adds up to be negative 47x. Okay, to multiply, get 150. How about 50 and 3? So if I had a 50x and a 3x, if I made the 50x negative, the 3x positive, they would add up to this, and they'd multiply to be that. So I'm going to take the middle and replace it with those two terms because it's still equivalent to the line before it. You want to factor out the greatest common factor of these two, factor out the greatest common factor of these two, and then those two products have an x minus 5 factor in common. And you got it factored. But again, if you trial and error, when you get good at it, it's quicker than this. And you don't have to worry about remembering how to do it. But yeah, some of you just need just a way to do these. Okay.